So function notation allows us to differentiate one equation versus another. So here we have f of x equation. Okay, f of x is one calculation for y. And then we have a different equation, g of x, and we want to make sure we don't mix them up. So we put one, we call one f, we call the other one g. So that's kind of the first layer of this, is that it allows us to separate two different equations. It allows us to keep track of two different equations. The other part of function notation is how we use function notation to show input and output, or our x variable and our y variable, our domain and range. So the f of x notation, when we write it like this, f bracket 2, this does not mean f times 2. This means f of 2, which means that we are going to take the f function, that f function there, and we're going to replace the x's with 2's. So everywhere we see an x in that equation, we're going to replace it with a 2. Okay, so it looks like this. I have 8x squared plus x minus 9. Okay, so there's my f function. And what I'm going to do then is I'm going to take that 2, and instead of where all the x's were, I'm just going to input a 2 into that expression. Okay, so there's my input. When I do the function, I'm going to get my output. So my f of 2 is going to then equal 8 times 2 squared plus 2 minus 9. This becomes 32 plus 2 is 34, minus 9 works out to be 25. So we say then that f of 2 is equal to 25. And what that means then is, if I make a table of values, there's my x, there's my y, x is 2, y is 25. It allows me to get an ordered pair in the relationship. Okay, so we can write it like this. So this implies that we can get this. We can also imply that we have an ordered pair, 2, 25, and we can put that in a table. We can put that on a graph. Okay, so this is what this function notation means. My input 2 is my x. My output 25 here is my y, and that's the result of this calculation that I did on the f of x function. Okay, so let's try a couple more of these. Okay, if I have f of -1, the first thing is I need to identify the function I'm dealing with. It's the f function. So it's 8x squared plus x minus 9. The input is going to be -1. So I'm going to input -1 into my function. Okay, the output calculation based on that function 8x squared plus x minus 9 is going to be 8 times -1 squared. -1 squared is positive, so we get 8 minus 1 minus 9. That works out to be -2. So with my function notation, I say that f of -1 equals -2. So my input is -1, my output is -2. So I can put it in my table of values, -1, -2. Okay, there's my input and output. Okay, it can also be shown as an ordered pair, right? As we can say the ordered pair is going to be -1, -2. Okay, we can write it as an ordered pair. So this is what this function notation allows us to see. So the first part we learned was that the function notation allows us to differentiate f and g. Okay, so g is a different function. So when I say g of 1/2, so this is how we read it, g of 1/2 means I input 1/2 into the g function. So then I start with the g function, 2 times x plus 3. The 1/2 means I input the 1/2 into this function. So I input 1/2 So that's not negative 1/2, that's positive 1/2. Okay, and when I do this calculation then, I end up with 2 times 1/2 plus 3, that is equal to 4. So that means then that g of 1/2 is equal to 4. That gives me an x and a y in a table of values as an ordered pair. My input and output is going to be 1/2 for x, 4 for y. Okay, so that's how we can get inputs and outputs for our function using the function notation.